Hi guys, it's me Gopalnath here. So guys, today we're going to see JEE mains mock test questions. So let me start to solve guys. The first question is, let cos of alpha plus beta is equal to 4 by 5 and sin of alpha minus beta is equal to 5 by 13, where your alpha comma beta lies between 0 and pi by 4. Then they're asking us to find the value of tan of 2 alpha. So guys, basically, if you need to solve this question, you need to be thorough in trigonometric formulas. That's the first point. And the next one is, you need to understand the question well. Use the information in the question wisely, interpret it and convert into another form. That's what plays a vital role in this question. Okay? So, what I'm going to do is, in the question they are given us the values of cos of alpha plus beta and sin of alpha minus beta, right? So I'm going to convert those values in terms of tan. I'm going to convert those ratios in terms of tan. So when I convert cos of alpha plus beta, so cos of alpha plus beta is equal to 4 by 5. So when I convert that into tan of alpha plus beta, I will be getting the answer as 3 by 4. I will be getting the value of tan of alpha plus beta as 3 by 4. How I am saying means, that's by using a triangular method. I will say, what is your triangular method? So let me say this angle as alpha plus beta. So as they are saying, cos of alpha plus beta is equal to 4 by 5. What is cos of alpha plus beta? That is nothing but adjacent to the hypotenuse. So adjacent is 4 and hypotenuse is 5. So adjacent is 4 and hypotenuse is 5. So as your cos of theta is nothing but adjacent divided by hypotenuse. So cos of alpha plus beta is equal to adjacent divided by hypotenuse, which is 4 by 5. If hypotenuse is 5 and adjacent is 4, what will be the value of opposite? That will be nothing but 3. How I am saying this means, that's by using our Pythagoras theorem. You know Pythagoras theorem, right? 5 square minus 4 square is equal to 9. Root 9 is equal to 3. And that's why I am saying your opposite is 3. If your opposite is 3, then I would say tan of alpha plus beta will be equal to 3 by 4. How I am saying means, as tan of theta is nothing but opposite by adjacent. Same like here, when I need to convert the sine of alpha minus beta. Sine of alpha minus beta is equal to 5 by 13. When I need to convert that into tan of alpha minus beta, what I will do now? You itself tell me what I will do now. Here also the same triangular method. So in here, your angle will be alpha minus beta, because I am having sine of alpha minus beta as only 5 by 13. So sine of alpha minus beta is equal to 5 by 13. That means your opposite is 5 and hypotenuse is 13, because sine of beta is nothing but opposite divided by hypotenuse. So what will be the value of adjacent? That will be nothing but 12. How I am saying? Pythagoras. So 13 square minus 5 square will be nothing but 144. So root of 144 is equal to 12. If your adjacent is 12, then tan of alpha minus beta will be nothing but 5 by 12. 5 by 12, as tan theta is nothing but opposite by adjacent. It's very simple. I'm just using a triangular method to convert the cos of alpha plus beta into tan of alpha plus beta and sine of alpha minus beta into tan of alpha minus beta, just by using a triangular method and Pythagoras theorem. Okay, va? So now we have found two values. What values we found? We have found that tan of alpha plus beta is equal to 3 by 4 and tan of alpha minus beta is equal to 5 by 12. These two values we found now. At the end of the problem, you will be knowing what is the reason behind converting this cos of alpha plus beta into tan of alpha plus beta and sine of alpha minus beta into tan of alpha minus beta. At the end of this problem, you will be knowing that. Okay? Now, in the question they are asking us to find the value of tan of 2 alpha. So what is tan of 2 alpha? What is tan of 2 alpha? Tell me one thing. Can't I write this particular term tan of 2 alpha as? Can't I write this? Guys, listen carefully. Can't I write this particular term tan of 2 alpha as tan of alpha plus beta plus of alpha minus beta. Can't I write like this? Think carefully and say. Can't I write this particular term tan of 2 alphas, tan of alpha plus beta plus of alpha minus beta? Anyway you will be getting 2 alpha as the inside value, as beta minus beta will get cancelled and alpha plus alpha will be 2 alpha. Anyway your inside value will be 2 alpha. That's not a problem here. I'm just writing this tan of 2 alphas, tan of alpha plus beta plus of alpha minus beta. But what's the reason behind doing such things? Why I need to convert cos and sine into tan? Why I need to write this 2 alphas, alpha plus beta plus of alpha minus beta? Now you will be knowing those reasons. Okay. Actually, here I'm going to take this alpha plus beta as one particular term. That's why I had put the bracket. And I'm going to take alpha minus beta as one particular term. That's why I had put the bracket. Why I'm doing like that means, in order to use your tan of A plus B formula. What is tan of A plus B formula? Tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. This is what your tan of A plus B formula says now. This is what your tan of A plus B formula says. So tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. So here your A value is alpha plus beta and B value is alpha minus beta, and that is the reason why I took this expression as one particular term and this expression as one particular term. Okay, I hope you guys would understand what's the reason. So here your A is alpha plus beta and B is alpha minus beta. When you use this formula, I will get tan of alpha plus beta, tan of A plus B as tan A plus tan B. What is tan A plus tan B? That is nothing but tan of alpha plus beta plus of tan B. What is tan B? Tan of alpha minus beta, because A is alpha plus beta and B is alpha minus beta, divided by 1 minute guys, I will take another chop piece. Yes. Now divided by 1 minus tan A tan B. 1 minus tan A tan B means 1 minus tan of alpha plus beta into tan of alpha minus beta. Just by using your tan of A plus B formula, I would write tan of alpha plus beta plus of alpha minus beta, tan of alpha plus beta plus of tan of alpha minus beta will be 1 minus tan of alpha plus beta into tan of alpha minus beta, just by using this formula. So do we know the value of tan of alpha plus beta? Of course we know. At the beginning of the question itself I found out that value. And do we know the value of tan of alpha minus beta? Of course we know. Of course we know. At the beginning itself I converted this cos and sine in terms of tan, and that is the reason why converting those values in terms of tan. In order to solve this big expression, I found out the values of tan using cos and sine. Okay va? So what is the value of tan of alpha plus beta? That is 3 by 4a. What is the value of tan of alpha minus beta? That is 5 by 12a divided by a, divided by 1 minus 3 by 4 into 5 by 12, and when you solve this you will get the answer as 56 by 33, and that's the answer for this question. It's a beautiful question. So 3 by 4 plus 5 by 12 it will be 1 minus 3 by 4 into 5 by 12 will be 56 by 33. The main part is you need to arrive tan of alpha plus beta and tan of alpha minus beta by the given information. Why I am arriving at that point is, in order to solve this big expression, I found out those values. Because here we are having tan of alpha plus beta and even we are having tan of alpha minus beta. So in order to solve this big expression, I found out those values by the information given in the question. So your answer is 56 by 33. So that's all guys. Let us move on to our next question. Our next question is, if limit of x tends to infinity of 1 plus a by x minus 4 by x square to the power of 2x is equal to e power cube, e power 3, then a is equal to what? So guys, how I am going to solve this question is, before approaching this question, you guys should be thorough in some of the limit properties. some of the limit solving methods, some of the indeterminate forms. After that only you can solve this question easily. Because guys, I need to say you one thing. If you need to solve this particular limit, what will you do? You will put your x as infinity. But in this limit, if you put your x as infinity, you will be getting it as 1 power infinity. Correct now? Check it and say, if you put your x as infinity in this particular limit, you will be getting the answer as 1 power infinity. And this 1 power infinity is an indeterminate form. This 1 power infinity is one of the 7 indeterminate form. So there is some separate technique to solve this particular 1 power infinity form. So what is the technique is, if I have a limit like limit of x tends to a of f of x to the power of g of x. If I solve this limit by putting x as a, if I get it as 1 power infinity form, I can write the same limit as e power limit of x tends to a of f of x minus 1 into g of x, and this is something our 1 power infinity form solving method says. Very simple now. Limit of x tends to a of f of x to the power g of x. If you get the value of the limit as 1 power infinity form, then you can write the same limit as e power limit of x tends to a of f of x minus 1 into g of x. This is the same technique I am going to use this in this particular limit. Okay. So what I am going to do is, here your f of x is the base. In this limit, your 1 plus a by x minus 4 by x square is f of x. And in this limit, your g of x is the power. So power is 2x. So g of x is equal to 2x and f of x is equal to this base. So I can write the same limit as e power limit of x tends to infinity, because x tends to a, same limit, x tends to infinity of f of x minus 1, base minus 1. When you subtract like that, you will be getting a by x minus 4 by x square. Because guys, f of x minus 1 is base minus 1. 1 plus a by x minus 4 by x square minus 1. 1 minus 1 will get cancelled and you will be left out with a by x minus 4 by x square into the power into g of x will be nothing but into 2x. Correct now? And that will be equal to e cube. That's the final statement that we got up to now. Okay, now what I am going to do, listen carefully guys, I am going to multiply this 2x with this inside expression. I am going to multiply this 2x with this inside expression. When you multiply like that, you will getting it as limit of x tends e power limit of x tends to infinity of 2a, because 2x into a by x is 2a, then minus of 8 by x. This is what you will be getting when you multiply this 2x inside the bracket, because 2x into a by x will be 2a, 2x into minus 4 by x square will be minus 8 by x, and that should be equal to e cube. If this statement is true, then of course your limit of x tends to infinity of 2a minus 8 by x will be equal to 3. Correct now? So what I am basically saying is, when you multiply 2x with the inside expression, you will be getting e power limit of x tends to infinity of 2a minus 8 by x is equal to e cube. If this statement is proved, then of course your power of this LHS will be equal to the power of this RHS. Okay va? Because e power limit of x tends to infinity of 2a minus 8 by x is equal to e cube means, then of course this statement should be proved. This is the basic laws of exponents which you guys already learned. So if this statement is true, then I can say that this 8 by x will be 0 when your x tends to infinity. Correct now? This 8 by x will be 0 when your x tends to infinity. So I can write it as 0. This 8 by x will be 0 when your x tends to infinity. Why? Because I am having x in the denominator. 8 divided by such a large number, that means infinity, will be 0 now. 8 by x when your x tends to infinity will be nothing but 8 divided by such a large number. 8 divided by such a large number will be almost 0, right? Almost equal to 0. That is why I am writing this 8 by x as 0 when it x tends to infinity. So directly I will get the limit as 2a is equal to 3. If 2a is equal to 3, then of course your a is equal to 3 by 2. And that's the answer for this question. So the answer is 3 by 2. That's all about this question. Let us move on to our next question. Our next question is, if y is equal to coordinates of 2 plus coordinates of 8 plus coordinates of 18 all the way up to infinity, then find the value of tan of y. So the options are pi by 6, pi by 4, pi by 3 and none of this. So guys, some legends can solve this question within fraction of seconds. Some people can solve this question within fraction of seconds. So how they can do it is, guys, listen carefully. Inverse trigonometric function of any value will give us some angle now. Inverse trigonometric function of any value will give us some angle in terms of pi, in terms of radians. So coordinates of 2 will give us some angle. Coordinates of 8 will give us some angle. Coordinates of 18 will give us some angle. And sum of all those angle will also be an angle. That means your y is also an angle. Correct now? Coordinates of 2 is an angle, coordinates of 8 is an angle, coordinates of 18 is an angle, and if it goes on up to infinity, for those values also it will be an angle. So sum of all those angles will also be an angle. That angle is only y. So tan of y will be tan of that angle. Tan of sum of angle will be a value. Correct na? If this summation of y is an angle, then tan of that angle, tan of y will be a value, will be a constant. Either it can be 1, either it can be 2, but we don't know. But in the options, we are not at all having the value, we are only having the angle. This shows that none of this is the correct answer for this question. This is a good way to solve this question. But guys, don't think that I will just escape by saying the simple things. I will solve this question step by step as the process. Because this question requires a process. Okay. So listen carefully. I will say how to solve this question. So what you need to do is, first find out anyway D is the correct answer for this question. So find the general term for this particular series. Find the general term for this particular infinite series. So the general term is nothing but the nth term. So I can represent the general term as Tn is equal to cot inverse of 2n square. This is the general term of this particular series. How I am saying this means, guys, observe the pattern, guys. It's not very difficult. Just need to observe the pattern. Observe every element of this series. Then only you can find out that. Because when you put 1 in place of n, you will get coordinates of 2. When you put 2 in place of n, you will get coordinates of 8. When you put 3 in place of n, you will get coordinates of 18. So it goes on up to infinity. That means this is the general term of this infinite series. Now, if I know the general term of that series, and if I am supposed to find a summation of those series, what will I do? I will put sigma of that general term. That is sigma of cot inverse of 2n square from n is equal to 1 to infinity, because this is an infinite series. What I said is, if I have a general term and if I am supposed to find the sum of this infinite series, what will I do? I will put sigma of the general term from n is equal to 1 to infinity as is the infinite series. Now the process starts. The first thing which I am going to do is, I am going to convert this cot inverse in terms of tan inverse. So cot inverse of 2n square can be written as tan inverse of 1 by 2n square. Correct now? Tan inverse of 1 by 2n square. Just by converting your cot inverse in terms of tan inverse. Guys, this is a process, manipulation. So you need to understand this. So tan inverse of 1 by 2n square, like that I converted. I just convert this term cot of 2n square in terms of tan inverse. That will be tan of 1 by 2n square, because tan theta and cot theta are reciprocal relation. Then of course this is right. So cot of 2n square is tan of 1 by 2n square. After this, I am going to do some edits. I am going to do some changes in the inside value of this particular expression. Inside value means 1 by 2 1 square. I'm going to do some changes in this inside value. So what I'm going to do is, I'm going to multiply by 2 on both numerator and denominator. Guys, please listen, this is a very good question. So you need to multiply by 2 on both numerator and denominator. When you multiply by 2 on both numerator and denominator, I will get 2 by 4n square. So I just multiply 2 on both numerator and denominator. At the end of the problem, you will be knowing the reasons behind doing this. Because guys, you can't just solve this question by seeing one question. You need to solve 15 to 20 questions of this same variety, and then only you can approach this question and you can solve within fraction of seconds. Okay. So I just multiply 2 on both numerator and denominator. After this, in the denominator, I'm going to add 1 and subtract 1. In the denominator, I'm going to add 1 and subtract 1. When I do like that, I will get summation of n is equal to 1 to infinity tan inverse of 2 divided by, I'm going to add 1 in the denominator and I'm going to subtract 1. Add 1 and subtract 1. I just added 1 in the denominator and subtracted 1. Anyway, you will be getting 4n square in the denominator. But this is a process. You need to do that because you will be knowing the reason at the end of the problem. Okay, va? So why I'm adding 1 and subtracting 1 is, what is this term? What is this 4n square minus 1? That looks like a form of a square minus b square, which is a plus b into a minus b. So 4n square minus 1 is nothing but 2n square minus 1 square. 2n square minus 1 square. It looks like that form, right? Because 4n square minus 1 is nothing but 2n whole square minus 1 square. Now I can write this as summation of n is equal to 1 to infinity of tan inverse of 2 divided by 1 plus 2n plus 1. 1 plus or 1 minus? Yes, plus only. 2n plus 1 into 2n minus 1. That's what I wrote. So because 4n square minus 1 is something but 2n plus 1 into 2n minus 1 using a square minus b square identity. Because 4n square minus 1 is something but 2n square minus 1 square, which is 2n plus 1 into 2n minus 1, a plus b into a minus b. Now in the numerator guys, is very important. In the numerator, can't I write this 2 as 2n plus 1 minus of 2n minus 1. Can't I write like this? Think carefully and say, can't I write this particular term 2 as 2n plus 1 minus or 2n minus 1? Anyway will be getting 2 because 2n minus 2n will get cancelled. 1 minus of minus 1 will be 1 plus 1 will be 2. Anyway will be getting 2 in the numerator. But what is the reason behind doing such things? In order to use tan is of a minus tan is of b formula. In order to use tan of a minus tan of b formula, I am doing such manipulations. Okay. So after this, what you need to do is, listen carefully. We know what is tan of a. I will rub this guys because you don't need it now. So you know one formula of inverse trigonometry, right? Tan of a minus tan of b is equal to tan inverse of a minus b divided by 1 plus ab. This expression looks like this form now, because summation from n is equal to 1 to infinity of tan is of 2n plus 1 minus of 2n minus 1, it will be 1 plus 2n plus 1 into 2n minus 1. Here your a is 2n plus 1 and b is 2n minus 1. In the denominator also 1 plus a is 2n plus 1 into b will be nothing but into 2n minus 1. Same expression, so I can write it as summation of n is equal to 1 to infinity of tan inverse of 2n plus 1 minus of tan inverse of 2n minus 1. So this is what you will be getting. And now I just use this formula, tan of a minus tan of b is tan of a minus b to 1 plus ab. So using that only I am writing this summation of this one, where your a is 2n plus 1 and b is 2n minus 1. Now I will take another choice because this is not writing properly. Now guys, try to expand the summation. That means put 1 in place of n, put 2 in place of n, next put 3 in place of n, and all the way up to infinity. When you put like that, When you put like that, finally you will be getting the answer as tan inverse of infinity minus tan inverse of 1. So what is tan of infinity? Pi by 2. What is tan of 1? Pi by 4. So pi by 2 minus pi by 4 will be equal to pi by 4, and that's the answer for this question. That is not the answer for this question. That is the answer for y. Tan of y will be tan of pi by 4. So tan of y will be nothing but will be equal to 1, because y is only is equal to pi by 4. So tan of pi by 4 will be 1. Okay, so what I did is just you need to put 1 in place of 1, next put 2 in place of 1, next put 3 in place of 1. When you put all the way up to infinity, most of the terms will get cancelled and you will be left out with 2 terms. That is tan of infinity minus tan of 1. Tan of infinity is pi by 2, tan of 1 is pi by 4. So pi by 2 minus pi by 4 is pi by 4. Pi by 4 is only the value of y. Don't directly and tick this B. Don't directly and click this B. Y is only pi by 4. They are asking tan of y, so tan of pi by 4 will be gone. That's the answer for this question. So none of these is a correct answer. Okay, that's all about this question. Let us move on to our next question. Our next question is limit of x tends to 0 of sine of pi cos square x divided by x square. So guys, what you need to do is you need to know some of the trigonometric formulas already. Because guys, you need to apply some of the trigonometric formulas as well as some of the standard limits. That is very important to solve this question. Okay, so first what I'm going to do is I'm going to write this particular term cos square x as 1 minus sine square x. I can write like that now. I'm going to write this cos square x as 1 minus sine square x. I can write like that now because that's the Pythagorean identity. So using that, I can write it as limit of x tends to 0 of sine of pi into cos square x. I'm going to write this cos square x as 1 minus sine square x. How I'm writing this means, as we know, sine square x plus cos square x is equal to 1, which is your Pythagorean identity. Using that, I will say that your cos square x will be nothing but 1 minus sine square x. Very simple. Now, you need to divide by x square. Now, you are going to do the basic multiplication by opening the bracket. So, I am going to do the basic multiplication in the numerator. When I do like that, I will get limit of x tends to 0 of sine of pi minus pi sine square. Just I am multiplying the pi with inside expression by opening the bracket. That's what I am doing now. Divided by x square. So, what I did is, just I multiply this pi. Just I multiply this pi with the inside value. Pi into 1 will be pi. Pi into minus sine square will be minus pi sine square x. That's all. Very simple. Now in this part, I am going to take this pi sine square x as some theta. I am going to take this pi sine square x as some theta. When I take like that, this looks like a form of sine of pi minus theta. Correct now? When I take pi sine square x as theta, then the numerator looks like a form of sine of pi minus theta because your theta is pi sine square x. So your numerator looks like a form of sine of pi minus theta. What is sine of pi minus theta? Sine theta. Sine theta, and that is why I said you should be pakka in trigonometry formulas before solving this. So when you put theta as this expression, you will be getting the numerator sine of pi minus theta. What is sine of pi minus theta? Sine theta. So using that, I will say that this limit can be written as limit of x tends to 0 into sine of pi minus theta will be sine theta. Sine of sine theta. What is theta? That is pi sine square x. That is pi sine square x divided by x square. This is what the limit that we arrived now. Okay. So basically I took this particular term as theta. So sine of pi minus theta is sine theta. What is sine theta? Sine of pi sine square x. Because I took theta as your pi sine square x. That's all. Very simple. Now I will rub this. The next part which I am going to do is I am going to use your standard limits, guys. That's very important. Standard limits. But before using that, listen carefully. Before using that, you need to multiply some value and divide some value. So see what I am doing. sine of pi sine square x divided by x square. This is what we are having now. Now I'm going to multiply this. I'm going to multiply this expression by pi sine square x and divided it by pi sine square x. That is what I'm doing now. Here the limit, right? Limit of from x tends to 0. So I'm going to multiply this same limit only. I just showed the same limit. I'm going to multiply it by pi sine square x and divide it by pi sine square x. Basically, both these values will get cancelled and you will be getting one which is the same expression. There is no changes going to happen by multiplying this and dividing this, because I'm multiplying the same expression and dividing the same expression. So nothing going to happen. But what's the reason we are doing such thing? What's the reason is, listen, what is this? Sine of pi sine square x divided by pi sine square x. Your sine of pi sine square x divided by pi sine square x will be 1 if your x tends to infinity. Do you guys forget that? That's one of the standard limit na. Limit of x tends to 0 of sine theta divided by theta will be always equal to 1. Very important standard limit. Very important. So sine of pi sine square x divided by pi sine square x will be 1 when your theta tends to 0. That means, sorry, x tends to 0. Okay, never forget that. Sine of pi sine square x divided by pi sine square x will be 1 when your x tends to 0 using this particular standard limit. So as your limit of, guys, I should write theta, right? Sorry. I should write theta. Sorry, I should write theta. So limit of theta tends to 0 of sine theta by theta will be always 1. As here, your x tends to infinity, sine pi square x, pi sine square x divided by pi sine square x will be 0. Sorry, will be 1. Because here, sine of pi sine square x is one value divided by the same angle will give us the 1. Now, when this give us 1, I can write as 1 into pi sine square x divided by x square. What is sine square x divided by x square? Same standard limit. Same standard limit. Sine square x divided by x square will also be 1 when your x tends to 0. When your limit of x tends to 0. So sine square x divided by x square will be 1 when your x tends to 0 as using this property. Limit of theta tends to 0 of sine theta by theta will be always 1. Never ever forget that. By that property only I am saying sine square x divided by x square will be 1 when x tends to 0. Then we are having this pi here. So I will multiply into pi. So answer is pi. So pi is the answer for this question. So what I use is this main standard limit. Limit of theta tends to 0 of sine theta by theta will be always equal to 1. That's how I solve this. Because sine of pi sine square x divided by pi sine square x will be 1 using this property, and sine square x by x square will be 1 using this property. So 1 into pi, because this pi is left out now. So pi is the answer for this question. That's all about this question. Let us move on to the next question. Our next question is, if the variance of 10 natural numbers 1, 1, all the way up to k is less than 10, then find the maximum value of k. So guys, what is the formula for variance? Tell me. The formula for variance is summation of xi square divided by the total number of elements minus of mean square. This is what the formula of variance. What is xi? Xi means each and every element of that particular sequence. Xi is nothing but each and every element. So summation of xi square will be nothing but sum of square of each and every element. Sum of square of each and every element is what represented as summation of xi square. And we know what this mean, right? Sum of all the observation divided by total number of observation. Now, when I need to find summation of xi square, I need to square each and every element and add it. Sum it up. So when I do like that, I will get 1 square a plus 1 square a plus 1 square a all the way up to k square divided by the total number of elements. What is the total number of elements for this particular question? That is 10. Then minus of mean square. What does mean? Sum of all the observation divided by the total number of elements. So sum of all the observations will be nothing but 1 plus 1 plus 1 and it goes on up to k. Then divided by total number of elements. What is total number of elements? 10 only. Then square. Because in the formula we are having mean square. Never forget that. In the formula we are having mean square. Now I will rub this, guys, because don't forget this formula. Because we don't need after this. So 1 square plus 1 square plus 1 square all the way up to k square. Here 1 square will be 1, 1 square will be 1. So you don't need to put it as 1 square itself. You can directly write it as 1 plus 1 plus 1 all the way up to k square. Because 1 square will be 1 now. So if I put it as 1 square, it looks like a complicated one. But when you write it as 1 itself, it looks like easy for you. It looks like it makes you happy. Okay, if you have 1 square, for example, if we have 5 square and if we have, I don't need to say 5 square and all. For example, if you have 65 square and if I have 65, you will be happy with 65 only, na? Like that only I am saying. So 1 square is 1 only, so I don't need to complicate it. So I wrote it as 1 itself. So 1 plus 1 plus 1 all the way up to k square. Here, this 1 is repeated 9 times. But this k square is only 1 time. As your 1 is repeated 9 times, I can write this as 9 plus k square divided by 10. As this 1 is repeated 9 times, because the 1 is repeated 9 times, because there are total 10 elements. Out of 10 elements, k square is 1 element and remaining is 9 elements. Those remaining 9 elements is 1 only. Those remaining 9 elements is 1 only. So I wrote it as 9 plus k square, because 1 up to 9 times will be 1 added up to 9 times will be 9 only, plus k square by 10, then minus of 1 plus 1 plus 1 up to k will be nothing but minus of 9 plus k divided by 10 whole square. This is what you will be getting. Because guys, here also 1 is repeated 9 times and k is the last element. K is the one element and other elements are 9. Sorry, other elements are 1 and that 1 is repeated for 9 times. Is summed up for 9 times. So 1 up to 9 times will be 9 plus k divided by 10 whole square using the formula. Now I don't need this. So finally what you will get is 9 plus k square divided by 10, then minus of 9 plus k whole square will be what? That will be 81 plus k square plus 2ab. 2ab will be nothing but 18k divided by 100. Guys, what I did is very simple. 9 plus k divided by 10 whole square will be nothing but 9 plus k whole square divided by 10 square. 10 square is 100. 9 plus k whole square will be 81 plus k square plus 18k using a plus b whole square formula. Now, I need to take the LCM now. So, I need to multiply by 10 on both numerator and denominator of this particular term. When you do like that, I will get 90 plus k square. Sorry, 90 plus 10k square divided by 100. In order to make the denominator same, just by taking LCM. Because here I had 10, so I multiplied 10 on both numerator and denominator. This is what I got. So when you expand this, you will get 90 plus 10k square minus 81k. Sorry, minus 81 only plus k square then minus k square then minus of 18k divided by 100. Just I'm opening this because guys the denominator is same, so I can directly subtract them. 90 plus 10k square minus of 81 minus into 81 minus 81 minus into plus k square minus into plus 18k will be minus 18k. Now how can I write this? 10k square minus k square will be nothing but 9k square. Then you are 81k, so 81 90. Okay, now after this what you can do is 90 minus 81 will be 9, so minus 18k plus 9 divided by 100. This is what the final expression that we got. Actually 10k square minus k square will be 9k square. Then we are having only 1k value, so 18 minus 18k plus of 9 divided by 100. Now you can write this expression as 9 into k square minus 2k plus 1 divided by 100. Okay guys, I hope you understand what I am doing. 10k square minus k square is 9k square. Then we are only having 18k minus 18k, so I wrote it as minus 18k plus 19 minus 81. What is 19 minus 81? 9. That's what I wrote now. Now listen carefully. Can't I write this expression as 9 into k minus 1 whole square? Can't I write like this? Then divided by 100. Can't I write like this? Tell me. Can't I write this expression as 9 into k minus 1 whole square by 100? Because k square minus 2k plus 1 is k minus 1 whole square only, using a plus b whole square identity. A square minus b square, a square plus b square minus 2ab. So k minus whole square will be k square minus 2k plus 1. Now, do you guys forget one point? They are saying that the variance of 10 natural numbers is less than 10. We know that this expression is only variance. This expression is less than 10. Okay, va? This expression is less than 10. So this expression is less than 10. So when I multiply 100, so when I take that 100 to the RHS, not RHS, in inequality, what you will say? I don't know. So when you take 100 to the right hand side, you will get it as less than 1000. And just took that 100 to the RHS, you will get it as 9 into k minus 1 whole square is less than 1000. So what can I do is, I can get it as k minus 1 whole square as 1000 by 9. Because guys, I just took this 9 to the RHS, so you will get divided by 9. It's not equal, less than. Okay, so k minus 1 whole square is less than 1000 by 9. So k minus 1 will be equal to root of 1000 by 9. See this, you need to just solve this. 1000 by 9. So this will be nothing but k minus 1 will be equal to 10 root 10 by 3. Because root of 1000 is 10 root 10. Correct dana? So root of 1000 is something but root of 100 into 10. Root of 100 is 10, so I took outside. So 10 root 10 divided by 3. Because root of 9 is 3. Now if k minus 1 is equal to 10 root 10 by 3, then your k will be nothing but 10 root 10 by 3 plus 1. So when you solve this, you will get the value of k as 11.2. That means less than. Again and again and again, I am putting it as equal. Sorry guys, it's less than. Okay, sorry for that, it's less than. So k minus 1 is less than 10 root 10 by 3. So your k will be less than 10 root 10 by 3 plus 1. So I would say that your k is less than 11.2. Finally I got that guys. Sorry if I wrote equal to, that's by mistake. Okay, so k will be equal to k will be less than 10 root 10 by 3 plus 1. So k is less than 10 root 10 by 3 plus 1. So 10 root 10 by 3 plus 1 is 11.2. So k is less than 11.2. If it is less than 11.2, what will be the maximum value of k? It's obvious that your maximum value of k is 11. And that's the answer for this question. How I'm saying is, they are saying that all these 10 elements are natural numbers. Then of course, it shows that your k is also a natural number now. It shows that your k is also a natural number. If k is a natural number, it can't be 11.2. You can ask, why can't it be 11.1999999? No, because they're saying all those elements are natural numbers. So of course, k is also a natural number. So 11.2 less than 11.2, what natural number we have? 11 only. So 11 is the maximum value of k. That's all guys. Thank you. Make education simple.